One more thing about the energy regarding different atoms. So that's electronegativity. That's more useful compared to ionization energy and electron affinity. So we talked about earlier. So for that, what's the definition for electronegativity? Okay, electronegativity is ionization energy plus electron affinity divided by 2. So then you can, in another way, you can treat electron negativity as, so how much, what's a attraction force can nuclei, okay, element for a pair electron, okay, for a shared pair electron in a molecule, like say in the in, let's see, maybe this one is not good. And let's just talk about here. That's seal bond, okay? Then for this shared parity electron, the covalent parity electron here, okay? Then carbon and oxygen, they're going to have different, electronegativities. So let's look at the table, okay? Then carbon has 2.55, okay? And oxygen has 3.44. You can see this one, the oxygen has higher, larger electronegativity than carbon. That means in this carbon seal bond, the oxygen, has higher electron density of this electron pair than carbon. So that's a meaning of the electronegativity. So then let's give another example. Let's look at the nitrogen oxygen bond. So nitrogen has electronegativity as 3.4, and oxygen has 3.445. So in this way, we can say the oxygen has higher electronegativity than nitrogen. Then electron density here will be more, attracted by oxygen atom. So they share the electron here. Okay, where it goes more to this side. Okay. So that's about electronegativity. So if we look at this S block here, that's main group, S plus P block. That's main groups. And we will say electronegativity has same trend as ionization energy and electron affinity for atoms. So this way, we say increase. Okay, if we go same group, okay, group 1, we say decrease. Okay, and if we look at the other groups, we have similar trend. Okay, and from here, group 14, okay, we have larger one, and we have smaller one, and until here, the final row here, we see some larger numbers. So that's some exception here. Okay, we need to be careful. Okay, but general trend is you see it's keep decreasing, like group 15 keep decreasing. Group 16 also we have decreased trend. Okay, there are some couple exception here. Okay, don't worry, this still you can see we have exception here. Okay, let's look at the D block. In the D block, we have in the same row. Okay, the first group period 3, the first row transition metal, you can see nearly you have increase up to nearly copper, and we see a decrease here. Okay, and the second transition metal 1.22 and keep increase, small change here, but nearly we also see increase up to this point. Okay, but we have decrease neither here. And also we have similar trend here. Okay, we keep increase. Here we have some comparable one, an increase and mercury is smaller than gold. But in the same group, okay, say let's decrease, okay, decrease for group 3, and the decrease group 4, and here, and for group 6, we see some small changes, okay, and because of some F blocking the electron effect. So we don't worry about too much here. Just let's memorize the main trend. Group 7, become what? Become increase, okay? Become increase, okay? It's different here, almost different. Let's use a different color. Let's see. That's decrease, but here we see start to increase, okay? Increase in the chromium group 6 until here, okay? That's increase, okay? Okay, that's a deep lock. So we have different trends here, okay? That's very important for deep lock when we talk about the bonding energy reactivity of deep locks, okay? Especially for group 6 up to group 10. So those they are the essential metals used for catalysts and also other materials. All right. Then let's talk about another property about element. So that's about gasification for element from solid state. We call that atomization of element. So that means how much energy you need to convert atom to form a gas phase atoms. Okay, so that's a trend in these two figures. We can show trend. As you can see in the same row, period 2, period 3. Okay, that's main group. Okay, that's main group. That's main group here. So we can say it's increase first and then decrease. Same trend for group period 3. Increase, decrease. When it's increase, that means you need more energy to do gasification. Okay, but after this peak point, you decrease. Yeah. So that always, relate to the bonding interaction between atoms. So when we go up to 14 group, so the bonding keep increase between atoms, okay? But after 14 until 70 group, it's keep increase because when we fill more electrons, then electron will goes to anti-bonding orbital for the solid state atomic materials, okay? Then when as we expand in molecular orbital theory, if you put more electron into anti-bonding orbitals, then your bonding interaction between atoms will be weaker. So we have similar trend for deep lock here. So we increase and decrease at some point, okay? And the green trend here. So, but for the 3D, okay, 3D we have the trend is not obvious. It appears increase, but we have a decrease, increase. Okay, so not very clean here. So, but for the 4D and this 5D row, we do have this trend. And also for element, so atomic state elements, there are another important character we need to consider is metallic character. So when we talk about metallic character, that means either it's conductive or not conductive, right? So you can say, as we're showing here in this arrow, so from group 1 all the way to group 18, we see left to the right, we see the decrease of the metallic character for element. And we see from same group, if we from top to the bottom, we see the increase, okay, increase of metallic characters. That means as indicated here, so they are metals. Metals means they are conductive. That means they have free electron moving around in the at the Fermi level energy. Just record the, Fermi energy we talk about in the solid state chapter. And here the yellow one, so that means, okay, yellow one here, they are nonmetal, not conductive. Or you can call it, they are instate element. But here it's metal. But you see we have some, let's use a different color. So you can see here we have a transition region here. It's like a, sitting between metal and non-metal elements. So those are, we call that metalloid, or you can call it, it's a semiconductor element. We also examined earlier before, okay? Okay. That's metal character for elements. So lastly, we're going to talk about some information about